if you were to answer, why does deep learning works? Even after doing so many things wrong, why does deep learning works? First thing is, let's try to understand what exactly is deep learning or the deep learning systems. All of these deep learning systems that we use and that we have been using are the form of neural networks. All of these neural networks are trying to optimize or minimize a certain loss. Now, when they are trying to minimize this loss, they take a loss function like cross entropy and they minimize the loss function in order to produce a representation of the data that they're dealing with, and that representation is in higher dimensions. They're trying to learn the representations, right? So it's like, if we talk about transformers, they are trying to minimize the cross entropy loss between the predicted data distribution and a training data distribution, right? Now same as with the convolutional neural networks, same as with recurrent neural networks. So they are also operating on cross entropy loss and mean squared error depending on the problem that they are solving, right? All of these neural networks are trying to minimize a certain loss function, right? It might be mean squared error, it might be cross entropy loss, and they are trying to produce or take in raw data, produce a representation in a very higher dimensions, and then learn those dimensions, right? Learn parameters around those dimensions, which basically says that once I learn this data and the distribution, I will be able to behave like this behave like this data. I might be able to do next token prediction. I might be able to do image to text translation or image captioning, right? And these systems have very huge tendency of hallucinating, right? We understand now what they're doing, right? Trying to optimize a loss. So loss can be a cross entropy loss, k-set cross entropy loss, a binary cross entropy loss, mean squared error loss, right? Depending on the kind of problem they are solving. Are they solving a regression problem or a classification problem? Then with respect to transformers, they are trying to predict the probability, the conditional probability, right? Statistically, we think of them as stochastic and probabilistic systems, right? Why? Because main objective is to predict the token xt given the token sequence x1 to xt minus 1, right? So what is the conditional probability of token xt given the token sequence x1 to xt minus 1? And the cross entropy loss is being minimized throughout this process. Now, these systems have the tendency to hallucinate. These systems have the tendency to not understand any logical reasoning structure behind them. These systems do not understand any factual and truth statements behind what they predict, right? They're just simulating whatever they have seen in the training data, and what they have seen in the training data is nothing but the internet, right? Now internet is largely describing how the universe works. The main thing that these systems tend to work, and these systems are still helping us in so many cross-domain applications, and they are also able to exhibit cross-domain applications, is that the data is at so much scale. I mean, the data that we feed as part of the training universe is at such a high scale that they're able to learn the structure in the data, right? So scale is something that helps them produce whatever fluency they are able to produce. So the linguistic fluency that they're able to produce, the worldly wisdom that they are able to produce, and pretending with the confidence that they're that they know things about everything. This basically is coming from nothing but data. So huge amount of scale. And once we scale the training data, we observe that largely the universe has repeating structures. We have the universe, and in the data we have a lot of repeating structures. And these brute force deep learning systems, we are calling them brute force not because they are inefficient, but because they are simple equations, simple mathematical models trying to learn the representations of the data. They are not like physics based models. So the scale of the data is so huge that they are able to understand the repeated structure that is present in the data, and they are able to produce representations of that particular data and then memorize those representations in their large parameter suite. So as we scale the data, the model complexity and the amount of parameters that we have to go through that data also scales. Now as we scale both of them, the compute also scales, right? So this is largely the reason. I mean, the core crux and the core heart is nothing but data, and on this side we have number of parameters that makes things work, and that that helps us understand that these deep learning systems that makes things work So we have now boiled down to things that these models might not be the most intelligent models, but the underlying structure, the underlying architecture, and the hypothesis that they're working on, which is immense amount of data, which requires us to have immense amount of model parameters, so that the model parameters can learn the representations, the high dimensional representations of data. Along with that, now we need immense amount of compute, because we would want to run gradient descent, we want to run the forward pass and the backward pass in order to produce these representations and learn these representations and update our parameters, right? So at the end, scaling laws play the most important component or most important catalyst in making these brute force deep learning systems work. First is scaling law, and then the inherent nature of the universe, that the nature of the universe has is as such that there are a lot of repeated structures, and the entropy is very less in the universe. Variance might be very high, right? But the entropy in the universe, or the degree of uncertainty, is very less. Things are predictable, things have low entropy, and things are very much repetitive in nature. This is, I think, the crux of why deep learning systems work, even after suffering on a lot of dimensions. Like, they have the ability to hallucinate, they have the ability to not understand the physical and spatial structure of the world, they don't have the ability to continually learn, they don't have the ability to think like a human being or like a biological brain or reason like them, but still they seem to work. Thank you, I hope it was insightful. Cheers, see you in the next video.